Firstly, I'd like to acknowledge that I'm speaking to you from the unceded lands of the Ngunnawal and Ngambri people, the traditional owners of Canberra, and I pay my respects to the elders past, present, and emerging. So today I'm going to talk to you about individual differences in language acquisition. And what I mean by acquisition here is first language acquisition, and the data that I'll be talking about only speak to one context, and that's mainly monolingual children acquiring the dominant language of the community, and that's English. However, many of the ideas that motivate the study of individual differences are relevant to this population, so I hope the talk is interesting to everyone. So I'll give a brief overview of my talk. I'll first motivate the study of individual differences. Then I'll introduce the study on which a lot of the talk is based, which is a large longitudinal study of language acquisition in children aged 9 months to 5 years. I'll explain how individual differences emerge early in the cohort and continue to rear their head in interesting ways across the course of the study. And I think this leads to important insights about the acquisition process. Then I'll aim to draw these all together into some brief conclusions. So let's start with a quick demonstration of the extent of individual differences in acquisition. So the figure on the left here is data from the WordBank data repository. And this is for children who are requiring American English. So WordBank is a repository of MacArthur Bates communicative development inventories. So these are parental checklists for where parents mark whether or not their infant knows or doesn't know a particular word. And this gives us an estimate of their vocabulary and of their emerging grammar. So I've used the American English here only because it's the largest data set, and it really demonstrates nicely my point here about individual variability that's independent of age. What the figure here shows is the size of the productive vocabulary in children aged 16 to 30 months. Each dot here represents one child. So as you can see here at all age bands, we've got really large individual variability in their vocabulary size. So if we can just zero in on one age band, you can see here at 18 months, the children in the lowest quintile have only a handful of words. However, the children in the highest quintile have hundreds of words, right? And this is true of all of the age bands. Now, individual differences don't disappear after 30 months when children are just beginning the acquisition process. They continue right through the childhood, and I would argue even into adulthood. So if we look at the figure here on the right, the figure here is from the norming data of the test for reception of grammar. This is British English this time, but it's also normed in many other languages, this test. And what this graph here shows is the proportion of children who have mastered particularly late acquired structures. And the point here is that for all of these structures, there's at any age, there's a proportion of children who have mastered the structure and a proportion of children who haven't mastered the structure. So if we see here, for instance, for the most difficult structure for these children, the center embedded structures, at 9 years of age, very few children are actually passing this or have mastered it, and a lot haven't. If we go to an earlier acquired structure, such as the reversible passive, we find that almost 80% of 9-year-olds in the norming data have mastered the reversible passive. However, that means about 20% of children haven't. So hopefully what this demonstrates to you is that there's individual differences in language and they're pervasive in acquisition. And even though I won't talk about it, I think there's a good argument to say that they also persevere into adulthood. Okay, but in psycholinguistics, individual differences represent something of an inconvenient truth. So their presence is undeniable, but their importance is often downplayed. And I don't mean this intentionally. Importance is often downplayed because we often use things like the experimental method. In the experimental method, when we're comparing across groups or we're comparing across conditions within groups, what we're doing is we're consigning variance to error variance. And so we're not really trying to explain it, we're explaining it away. But really, if we take individual differences seriously, then it really is likely that some of this variance, at least, is not due to error, and that it's also systematic and can be explained as due to differences, for instance, in proficiency or differences in for other reasons. And this is important because an important goal of the cognitive sciences is to describe cognitive processes at the individual level. So we should be building theories, or hopefully the goal is not to just build theories of the average child or the average person, but to build theories that can say something and predict something about individuals and how they vary. And this is nicely embodied in a quote by Estes, who was a learning theorist last century. He wrote, "We cannot expect average data to yield any direct answer to the question, what is the form of the individual function?" So that's to say, when we look at group data, there's an infinite number of individual trajectories that could lead to the pattern of average data. And this means that if we're building theories that we want to speak to individuals, we can't solely do this using average group data, and that we should also study individual differences. So this is what I'm trying to motivate in this talk, the study of individual differences. Okay, so we've established that individual differences exist, but where do they come from? Excuse me, I'm having my morning tea. At first blush, we can make a distinction between endogenous or internal and exogenous or external sources of variation. Endogenous sources of variation include genetic, neural, and cognitive variation. And of course, variation at one level here is likely to be related to variation at other levels, although exactly how this plays out is perhaps not always obvious. So we assume that variation in genetic expression or gene expression can lead to things like variation in the neurological support for something like language, which would also rear its head at the cognitive level. But actually mapping between those levels is a very complex process. Exogenous sources of variation include input and interaction, but also context, which I'll talk about a bit later in the talk. So overall, while the likely sources of variation are large and often understudied, the assumption is that individual differences should be systematic and constrained such that their study should be in many respects tractable, even when one can't study all the possible sources of variation. So the study of individual differences is an important methodology to reveal the mechanisms, particularly in my case, mechanisms of language development, and in the words of Liz Bates, the seams and joints of the language processor. So I'm going to talk to you a lot about this particular study that we've been conducting over the last 10 years or so, actually, what started about 10 years or so ago, and it's called the Canberra Longitudinal Child Language Project, where we aimed to chart and explain individual differences in children's language and their environment from 9 months to 5 years. So I'll give you a little bit of an idea about the various features of the sample. We originally recruited 124 9-month-olds, and by the end of the study, when they were 5, we had almost 100 still. So we had fairly good retainment given the extensive testing and measurement that we did with our families. They were recruited via community advertisement. So this was convenience sampling, and we inherit some of the problems of convenience sampling that I'll come to later. They were typical birth weight. They're requiring English from birth with less than 20% exposure to another language. This is not because we think that that studying individual differences in multilingualism is uninteresting. It was just we just had to limit the scope of the project. In fact, individual differences in multilingual individuals is perhaps even more interesting than our sample. Because of our convenience sampling, our SES was high. Our median parental education was a bachelor degree. This is not uncommon, and this is slightly, well, not fully representative of Canberra, but it's Canberra because it's an administrative centre and because it's a planned city does have a higher than average education. We had a spread of parental education, but bear in mind that the actual sample itself is probably not representative of the population as a whole. So in the study, we measured both variation in typically emerging linguistic skills at different age points, as well as measuring the children's linguistic environment in different ways. So what we were trying to do at each age is identify important developments that likely have individual variation or individual differences, and we tested our cohort on those particular properties. So, for instance, at 9 months, we tested their segmentation from running speech, which I'll talk about in a moment. Then we did a lot on their vocabulary or lexical acquisition and processing, and this finally dovetailed into syntax. I'll talk about all of those three things today. I won't talk about the outcomes. At 5 years or 60 months, we did a bit of work on measuring their outcomes, which we tried to link to their performance or growth over time from 9 months, but we haven't quite fully got there yet. So stay tuned, maybe another time. So the first, I guess, lesson that we learned from this study was that from the earliest moment that we were trying to measure individual differences, we found them. And this is what we found in our first study of speech segmentation in the children. So at the beginning of the study, we looked at individual differences in speech segmentation. And this is one of the first tasks that children have to master in order to start constructing a language, which is to find words in continuous speech. So unlike the sentence here, the eagle is in the nest, in written form, it has spaces in between it, and this facilitates word recognition in a language like English. But this doesn't happen in spoken language. So children have to be able to find where words start and where they end in order to start building a lexicon. So we studied segmentation in the following paradigm. So children heard sentences like the eagle is in the nest, and then 300 milliseconds later, they heard either eagle, which was contained in the previous sentence, or a word that wasn't contained in that previous immediately preceding sentence, which was pencil. And we measured their reactions to these targets using EEG, as you can see there with the little child with the EEG cap on. So there were three conditions. The first was a direct familiar condition where they heard the target eagle when eagle was in the preceding sentence. So this was testing the segmentation, and we compared this against a baseline, which is our unfamiliar condition, where they heard pencil, for instance, if they'd never heard pencil within the study before or within the block that they were currently doing. We also had a sneaky in-between condition called the indirect familiar condition. So this is when they heard pencil after the eagle is in the nest, but they'd heard pencil 10 sentences before, about a minute before. So what we're doing here is testing their memory or their sort of delayed memory for a word that they may or may not have successfully segmented a minute previously. So what we found even at 9 months was really a range of abilities and children's capabilities in segmenting from running speech like this. So what we did find is one group who are really great segmenters. So what we're looking for here in the ERP waveform is a negative deflection to the target word, say eagle in the direct familiar condition from baseline. And what this graph here plots is the negativity upwards, which is standard for ERP research. So let me walk you through this graph. These children here in the direct familiar condition, so this is when they hear eagle after it being in the sentence, have this negative deflection in relation to the baseline, which is the green line. And this suggests that they're segmenting the word that they'd heard in the preceding sentence very well. Interestingly, they also show a relative negativity to this indirect familiar condition, showing that they're also quite good at identifying words that they've heard, say, 10 sentences previously. So these are a group of mature responders, as we call them. These are good segmenters. In contrast, we had children who were still on their way to getting to segment full words from running speech. So these children had an exact polarity shift in their ERPs. So they had a positivity in comparison to the negativity of the mature responders. And so what we think is going on here is these children are just at a different developmental stage. They're not segmenting the full words from running speech, but what they're probably doing is attending to lower level phonetic features, such as probably the stressed syllables in the words, and then recognizing the repeat of the stressed syllables across the sentence and the target word in isolation. Then, interestingly, we had another group of children who were in between, who were making the transition between being positive responders, so this sort of earlier developmental stage, into the more mature stage. So we found in this middle graph here a late, sometimes a late negativity in these children, which was indicating that they were moving towards being able to segment the full words from running speech. So the size of the negativity at 9 months in the whole cohort actually predicted their vocabulary size 6 months later when they were 15 months. And this association was still significant after controlling for variables like their vocabulary at 9 months, their parental socioeconomic status, and gender, suggesting that an early capacity to find words in the speech stream aids in building vocabulary. Okay, so we found these differences very early. So let's now talk about another source of individual differences that I referred to at the beginning of the talk, which is differences in the input, in the environment, and also, interestingly, in the context that changes the environment. So I think it's fairly self-evident that input plays a determining role in language development, but exactly how is a matter of debate. So we know from studies of deprivation that children who are deprived of input don't learn language. If you, for instance, only spoke 50 words to a child, they would only learn 50 or fewer words. But of course, language isn't that simple, thank goodness. And the complexity of the input and the way we use language means that being able to map how the input supports and influences acquisition is complex. So there's been a large emphasis on input quantity, but interaction plays a key role in early language socialization and therefore language development. So even in cultures where there's comparatively little direct input to children, linguistic anthropologists have identified important cultural interaction routines that form the basis of language socialization and therefore the basis of language development. In this case, if we take the idea that that early language and early support for language is importantly social, then a key unit of study here is the conversational turn, which I'll talk about in the next few slides. So in a paper based on the CLCL data, we've shown that the degree to which infants engage in conversational turns is predictive of their language over and above factors such as quantity of language in their environment. So we did this using the linear technology. So we measured the children's language environment using the linear technology. Some of you will know about linear, but for those of you who don't, I'll give you a brief explanation. So the linear technology is a way to get day-long recordings of children's language environment. So you can see here in this picture, the lady is putting a little recorder into a pouch in the child's overalls. And what this does is record the whole day of the child's language environment. After 12 or 16 hours, depending on how long you do it, you can plug that recorder into some proprietary software, as you can see in that computer there. And this gives you a whole bunch of indices of the children's language environment. One is the number of adult words in the environment. Another one, importantly for our purposes, is the number of conversational turns that the children engage in. We got leaner day-long recordings from the children from 9 months to 24 months, every 3 months. And we also recorded their productive vocabulary using the MacArthur-Bates Communicative Development Inventory, which I talked about before. So what we found is that, not surprisingly, we found that the number of conversational turns that the children are engaging in increases with development. But as you can see here, at each age point, there's really large individual differences here in the number of conversational turns that the individual children engage with or have, sorry. Not surprisingly, we also found that the children's productive vocabulary increased across age. But once again, we find, as in the word bank data, we find lots of individual variability in the children's productive vocabulary. Importantly, what we found is that growth in conversational turns and vocabulary reciprocally influenced each other, such that gains in one lead to gains in the other. So this suggests, rather than being passive participants in the acquisition process, children partly driving their own language development. So increases in vocabulary beget increases in conversation, which begets increases in vocabulary again. So that's to say, this is great evidence for a strong social basis for children's early language. In a different study, we've also found that conversational turns play an important role in early acquisition. This is from a different longitudinal study, because one longitudinal study is never enough, although this is a smaller longitudinal study, only lasting about 6 months. But what we found is that that the conversational turns and other parts of infant-directed language are tied to social context. So we had 54 caregiver infant dyads. So the children were 18 months at the beginning of the study, and we followed them up at 24 months. And they interacted in 2 contexts. One context was a symbolic play context. You can think of that as the picture on the left, where the mother and the child are pretending to use telephones to talk to each other. And the other one was a functional play context, which was where the caregivers and the children were engaged in what we think of as adult-defined tasks, such as completing a puzzle. So in symbolic play, toys like a pretend tea party set or pretend blocks that could be used as phones create symbolic context. So that's pretense or pretend play. And pretense is a challenging but rewarding context for children, since it requires a degree of negotiation of the ambiguity of reference. So what is this block in this context? Okay, so we have to work out what the block is and then what we're going to do with this new identity for the block, in this case, a phone. So in contrast, functional toys like puzzles simply require the dyad to complete an adult-defined task, which is complete the puzzle, right? So the rules are already there. The difference is the presence or absence of symbolic content, and thus whether the dyads must negotiate how to create that content. So interestingly, we found that this very small difference in the affordance of the toys creates very different communicative environments. So in symbolic play at 18 months, we found 3 times greater joint attention than in functional play. We find greater amounts of communicative gesture. We found greater amounts of questions, both yes/no questions and WH questions, which draw the children into the interaction. We found a greater use of mimetics or onomatopoeia, which recent research has shown can be important for scaffolding early vocabulary development. And we found, importantly, a greater number of conversational turns in symbolic play. In contrast, in functional play, we found a greater use of imperatives. Now, imperatives have been found very early in development to help children start to learn a few words, but once children develop more, they have something of a suppressing function of development, where they can be negatively related to subsequent vocabulary development. So the conversational turns, this is what we found. Conversational turns, like consistent with our previous study, was a consistent predictor of early vocabulary and grammar, whereas imperatives were a negative predictor. So it seems to be that this small change in the context which drew children in to start negotiating roles and negotiating the content of what was going on, created a much richer learning environment for the children. But of course, one important question concerns what exactly is going on during conversational turns. I think we don't really fully know this, but it's a great topic for anyone out there who's looking for a dissertation topic. We analysed the degree to which the dyads overlapped in their conversations across the 2 contexts using an NLP tool called Discursus. So you see a visualization here for one dyad. I'll walk you through it. This is for one dyad because Discursus doesn't combine all of them. But suffice to say, this is a really reliable pattern that we found. So we statistically confirmed it. So what the figures are is a bird's eye view of the conversation. So the diagonal line here represents time in the conversation. So the top left is the beginning of the conversation, and the bottom right is the end of the conversation. And the colored squares here represent when speakers are talking about recurring themes, when they have overlap in what they're talking about, which you can think of as a sense of alignment or common ground. So you can see that there's greater semantic alignment or greater semantic overlap in symbolic play condition. So there's more squares under the lines in the symbolic play condition than in the functional condition, which we attribute to the fact that the ambiguity of having to create the context means that the dyads have to negotiate meaning. So for instance, in this context, they have to agree that the block is the telephone and then decide on how the interaction scenario will play out, and it makes it a richer environment. This is why we see things like greater amounts of questions directed to the children. In a subsequent analysis, borrowing concepts and methods from conversational analysis, we found that infants are more knowledgeable conversational partners in symbolic versus functional play. So that is, they have greater epistemic command of the content of the interaction, and in many cases are initiating conversational turns or conversational turn sequences in comparison to functional play. So as you can see, subtle changes in context can create large differences in the children's linguistic environment and their participation in it. So finally, I want to demonstrate an example of how focus on individual variation can illuminate acquisition trajectories that might be difficult to observe at the heterogeneous group level, even when that group is tightly controlled in their age bands. So in the CLCL cohort, we used syntactic priming as one of our measures of grammatical acquisition. So priming tasks go like this, or our priming task went something like this. So we were looking at the active-passive alternation. So in the here, the children saw a picture of a transitive event such as this, and in the prime, the experimenter always described the prime picture. Here, using a passive, the bird was kissed by the monkey. Now, the children then described the target, and they did so in two conditions. In one condition, there was what we call lexical overlap in the target. So it's the same event. There's a kissing event going on here. And if the child uses a passive, such as the cow was kissed by the duck, then they're said to have been primed. In comparison to the lexical overlap or lexical booster condition, there was another condition where there was no open class lexical overlap or conceptual overlap here. So the participants were different and the action was different. So when they get this target picture, if they use a passive, such as the sheep was poked by the dog, then they're said to have been primed. Now, importantly, these two forms of priming have been argued to be due to two different mechanisms. So lexical boost priming is argued to be due to explicit memory. So the fact that they share the same action gives children a cue to the structure that they'd heard, and then they can therefore use the structure. In comparison, the abstract priming is argued to be due to sort of implicit processes or implicit processes driven by an error-based learning mechanism. I don't have time to explain it, so you just have to take my word for this here. Importantly, these two mechanisms are argued to have different developmental trajectories. Explicit memory increases with development, so the argument there is that lexical boost effect. Priming should get higher and higher as children get older, but the implicit or abstract priming effect is argued to decrease across development. And this is because it's driven by an error-based learning mechanism. When children have sort of weaker representations when they're first learning the passive, in this case, more instances of the passive will create greater amounts of priming because of their originally weaker representations. As they get stronger representations, the priming should be lower. And this is exactly what we found actually in our full cohort. So we find that across time, across the ages of the duration of the study in which we measured syntactic priming, abstract priming decreased in the full cohort, and the lexical boost or lexically based priming increased, which was a nice result. So there's a divergent pattern of the effects across time. However, the point that I want to make here is not just this. The decrease in the abstract priming was most evident in a subset of children who knew the passive at 3. So at 3, we had about half the children, give or take a few, were primed and knew the passive. Half the children didn't know the passive. When we created a homogeneous group at 3 of the children who knew the passive, then this decrease in priming, this developmental trajectory, was much more evident. We had much stronger evidence for it. And this is because when we were analysing the children in the full cohort, there were a mix of knowledges about the passive at that point. And that meant that the developmental trajectory, the sharp developmental trajectory, was obscured by the children's differences in their knowledge levels. So the point here is that developmental trajectories are best revealed by controlling for knowledge level. So let me wrap this all up now. So what I hope to have to convince you of, or at least attempted to convince you of, is that individual differences emerge from the very beginnings of language acquisition. So these differences have multiple sources. They can be endogenous or exogenous. And this means that often age is a poor proxy for developmental level. In almost every graph here, I've shown you the range of proficiencies that we find at different age levels. And this means that developmental phenomena and trajectories may be obscured if we don't understand individual differences. And finally, the structure of individual differences provides insight into the mechanisms underlying development. And I think this is one of the promises of individual differences designs, as in that they enable us to enable us to try and illuminate the mechanisms that are going on in acquisition. If you would like to read more about these, I have a couple of open access papers that you can check out if you'd like, and in a bit more detail, or they'll go into a bit more detail than I have today. Finally, I'd like to thank everyone who has worked on these projects. It's very hard to do this research, it takes a long time. And so all of these people, too many to name. And finally, I'd like to acknowledge all the funding and especially I'd like to acknowledge the families. So the families let us into their lives, sometimes when it was very obtrusive, such as getting day-long recordings and things like that, but they did so happily and enthusiastically. And yeah, they're the real stars of the show in this one. So thank you. I'm very happy to take your questions now.